fairly far along in development, and inhaled levofloxacin or Levaquin, very similar to Cipro, that presumably will be effective and safe and a great addition to killing Pseudomonas. And similarly, is amikacin, it's called Arikayce, I can't quite see it there. Oh yeah, it's right down there. Inhaled liposomal amikacin. So, things to kill Pseudomonas. Another bug that we deal with great concern is MRSA. And a lot of CF patients have their airways colonized with MRSA. And we have actually fairly good oral and IV antibiotics for MRSA, at least so far, until MRSA becomes more and more resistant. But we don't have inhaled antibiotics. And we want to use inhaled antibiotics more as a prevention than a treatment, just like we use Toby or Casein or so on, more as a prevention. And inhaled vancomycin. Vancomycin is an old intravenous drug that's very effective, and it's very effective for MRSA. It actually existed before MRSA existed, but it's a sort of a mainstay of MRSA treatment. But they're working with getting a formulation that will be just right for, not too irritating to the lungs and so on and so forth. And that's fairly far along in development, and hopefully will be up. So those are some of the main ones. Gallium, I know very little about it, but I've read a little bit about it. It's actually, gallium is a substance that has been used in radiology to do certain kinds of scans looking for inflammation. Gallium scans have been around for years. But apparently, gallium, when it's injected intravenously, is kind of an antibiotic potentiator. And organisms, bacteria, like Pseudomonas, they work together, they form a big sort of a colony, and there's what's called a biofilm that helps them to grow and hurts the patient because it makes the bacteria much more dangerous and also much more difficult to treat with antibiotics. And gallium apparently disrupts the biofilm. So they're now doing experiments where they can inject gallium, they're seeing if it's effective and safe and whatnot. And maybe there's other things like that too that will come along, as with all these others, new generations, maybe an oral drug or something. But it's another concept. Instead of just a new antibiotic, can we take our old antibiotics and somehow make them work better to kill the bacteria we want to kill? And then the final thing is gene therapy, first done in 1989, I will remind you, but difficult, and the basic difficulty has been, in a nutshell, that the best way so far to administer a normal gene and get it into the lungs and have it take over the cell and make a CF cell into a non-CF cell, work to transmit chloride and all that, is to put it in a respiratory virus. Well, that's not obvious. Respiratory viruses attack the lung and put their genetic material into the cells and cause all sorts of damage and so on during a respiratory infection. So the initial experiment, and really most of the experiments since then, have been with altered respiratory viruses, and they alter the virus so that it becomes an efficient carrier. It's like a Trojan horse. It brings in foreign material. So the efficient carrier of the normal gene you want to get in there, and they also alter it so it won't be, you don't want to get a major infection with that respiratory virus because anyone's so sick or maybe even die in the process. So that's what they've been working on. And the problem is they found very efficient viral carriers, but the treatment only lasts about 4 to 6 weeks, and then the new epithelial cells come along, and they're CF cells, so you need to do it again. So every month or two you have to inhale this substance and get it in there. And the second or third time around, the body says, hey, this is a foreign invader. I'm not going to let this in here. It destroys the virus, doesn't allow the new gene to come in. And that's, again, this is way beyond my capabilities to understand, but that's what I'm told, that that's the basic stumbling block they're still working on. One of the ways around that is to not use viral vectors, but to use viral carriers, Trojan horses, but to use other kinds. And there are fatty type of molecules called liposomes that they actually started looking at many, many years ago, around the time they started with the respiratory viruses. And they were pretty safe and the body wouldn't reject them, but they didn't carry the genetic material in very well. And apparently, there's been a lot of innovation since then, and they've solved some of the problems, such that the United Kingdom is now doing in its phase 2B trial of some kind of a liposome carrier that they're hoping to be effective and have apparently enough pilot data that is somewhat effective in actually doing a gene cure in the CF cells. So that's kind of one of the hot things right now. All right, so that's it. I also have to, as everybody's bailing out, except Dr. Chavez, who bailed in. Any questions briefly before I leave? Yes?
What is the actual functional or effective difference between Orcon and Kalydeco?
It's for a different gene mutation. So Kalydeco addresses the situation where there is a chloride channel, but the chloride channel doesn't open. Kalydeco opens it. Orkambi is for the situation where the channel is so abnormal that it gets ripped apart before it ever gets up to where at the top of the cell where it needs to be a channel. So Orkambi is two drugs. One drug helps it to get through and up to the cell surface, and the second drug opens it. So that's the concept. And then that V661 substitutes one. It's hopefully